We're here in Kerhonkson, New York with Jamie O'Shea.
Hi.
With Bjorn Qorn, and we're going to be talking solar-powered cooking of corn in 2 or 3 different ways.
Sure.
Out here. Beautiful country, and you couldn't pick a better day. Could have been a little cooler, but hey, what the hell, So thanks so much. This is fantastic.
Thank you.
So, so how did you? When did it dawn on you that solar energy might be kind of cool to use for stuff?
Well, my former career was as an artist, and I kind of played the character of an inventor, I would say. So I invented things that were not quite for this world, quasi-real inventions, and in those investigations, I started playing with mirrored dishes, like purely playing, and that got me interested in solar thermal in general, and I started researching it and had kind of a design epiphany, I guess. It's something that seemed like it had a real possibility that maybe I should try to make an actual invention out of. That I'm still working on behind you here 10 years later. And that epiphany was learning about solar bowls and the design concept that if you use a spherical optic to focus sunlight, you don't need to move the dish itself. You just track the sun by moving the receiver throughout the day.
Okay.
And I realized that meant that you could potentially make really giant ones built right into the earth. I started experimenting with that about just 10, even 11 years ago now.
Wow.
Digging holes in the ground and figuring out how to laminate them with reflective material. It was clear that we could build something up to a scale that might have a commercial application. And so I had a friend from college, Bjorn, of Bjorn Qorn, and he always wanted to start a popcorn company with a recipe for popcorn that he grew up with in western Minnesota, in corn country. And I was like, hey Bjorn, what if we used your popcorn company as a test of this solar project? It'd be a good story for the company, and it would allow us to probe the idea and see if there's any merit to it. And so we decided that we would pop popcorn for sale in grocery stores. We grow it now on his family farm out in Minnesota. In our first iteration, we built 5-meter spherical dishes into the ground, which we call solar basins. In this farm area, we found a generous farmer who was willing to take a risk on some wacky guys digging holes in his land. And we set up a little concession trailer, and those dishes, once they were commissioned and the kinks were worked out of them, were 4.5 kilowatt dishes that made popcorn at a commercial scale.
Oh, wow.
We'd schedule our production around clear days up here, which is not the best climate for clear days, but still about 1 out of 3.
Sure. So you're taking a big gamble, but at the same time, the big payoff, because you're taking it's free energy.
Right.
Yeah.
It's like space-based solar seems like kind of a weird idea because it's already space-based and it's already beaming down here. And in fact, I think if you concentrate it much past 1,000 watts per square meter, it becomes too dangerous anyway.
Yeah.
So those proposals are only going to be the intensity of sunlight, but it works for some reason.
Sure.
I'm just not clear.
Theoretically.
Yeah. So we built the company. We ran it that way for the first couple of years before we started to outgrow our dishes. The popcorn became popular, which is great, and we were able to start to earn a living doing it. We were in the process of taking on a big engineering challenge, which is heating a intermediate heat transfer fluid using the same dishes to pop popcorn indoors in more conventional equipment, so that it would be a kind of thing where we could hire people to run the daily production and in general not be out in the middle of the field in the middle of the winter popping our popcorn. But that was a very big engineering challenge with very hot oil that we deemed unsafe in the end, particularly after it burst into flames in tests. But we did pop some popcorn with that system before we decided that the alternative had plummeted in price by something like 3 or 5 times
massive.
in the course that we were working on solar thermal. So it was a clear, easy decision to switch to PV.
Sure.
And when we bought this old dairy barn that we converted into our factory that's behind us here, we outfitted it with 20 kilowatts of solar PV, and that provides more than the energy that our kitchen uses. Another advantage of PV is that it's making grid-tied electricity that we can use for all the other buildings' loads,
Sure.
so that over the course of a year, with the exception of heating, which is part solar through heat pumps, but there's still an oil furnace in there that's doing some of the winter heating. Other than that, that building is net zero and generates more electricity than it uses over the course of the year,
Sure.
which is fed back into the grid. And our commitment is to always generate more solar electric than we use in the kitchen, and we'll expand our array as our business keeps growing.
Sure.
But Bjorn Qorn's a business that solar cooking built. We're a successful company now, and we really got to start with solar cooking. My overall strategy for the movement, the thing that I'm advocating for is small commercial production. And it could be restaurants, but I will say that food for grocery stores, or food that is at least semi non-perishable, means that you can schedule around the sun.
That's
and,
right.
You get to a certain scale, and in a place where energy cost is a big enough concern, and it can be worth it commercially to do that.
Sure.
Especially if you're in a sunny location. But so our design is really focused on the big, and behind me is just a small test section here of a dish that'd be about 12 times as large, I think, is the prototype scale that I'm now ready to build. I have enough numbers from this to confidently build this next stage.
Sure.
And that would be a 10 kilowatt commercial oven that could be used for a variety of things. I'm playing with it as a roaster right now, but it could be set up as an oven to bake bread or bake anything. One of the ironic applications that I don't think this dish is quite suited for is popping popcorn.
Oh wow.
Without evacuated tubes, I think the stagnation temperature is too low to pop popcorn on a commercial scale. I haven't proven that definitively yet, but I'm not quite targeting it with this design.
Sure. So we'll look at that a little more closely later
Sure.
with the cameras and
Yeah.
everything. So you started with a bowl, and now you're switching.
Yeah,
to...
so when we started to outgrow these dishes, we also took a hard look at the sort of intrinsic flaws of the design. So it's a solar bowl. It is a section of a sphere, as if you just planted a ball
Right.
in the ground. And those were 120 degree sections of the sphere, so that's like basically a third of the sphere set into the ground. And because we're at a high latitude here, we had to sort of torture a tilt into them to get year-round operation, and that was a significant construction challenge for here. Closer to the equator, it would cease to be necessary. And we always had our eye on them being used in a different location.
Sure.
But
You're like about what, 40 or so?
41, yeah.
41. Okay.
Yep.
Yeah.
And the other big drawback of the design is, well, it was possible to make them big. The excavation does scale as the square of the power because it's a three-dimensional object. You are excavating cubic material to get square footage of incident suns,
Okay.
if that makes sense. So they were getting pretty big, and since they're built into the ground, actually, drainage is a significant design issue.
I was about to ask with those bowls, like those farmers probably said, well, if it fails, you got a little pond,
Yeah.
right? Just
And our first dish, which we had an active pump on, so there was a sump in it that would pump out rainwater. That was a pain. That was a mistake. It frequently wanted to try to turn into a frog pond, and it took a lot of our energy to prevent it from doing that. every dish that we've made since then has been passively drained, and that works great, but it adds a lot of excavation depending on your site.
Sure.
And so the shallower you can get the design, the better. Those two problems are the primary reason that I started pursuing a cylindrical optic as opposed to a spherical. And the idea is the same, where because it's a section of a circle, the dish will focus even if it's not lined up with the sun. You just need the receiver to be lined up with the sun. So it can be static, it can be built out of earth, but the excavation scales linearly with power because you can just extend the cylinder in one direction.
Sure.
If you want more power, you just make it longer. And a practical geometry for it will put the commercial scale oven that we're talking about at about 2.5 feet deep, as opposed to in the end our tilted dish was 7 feet deep, I think.
Wow.
Which
Okay.
limits
That's a
the
big
sites
difference.
that you can build something like that. And also sort of requires heavy equipment at that point. Just like a mini excavator,
Sure.
but it's beyond what reasonably could be dug by human hands. And the commercial scale cylinder that I'll build probably in southeastern Arizona over the next year could be dug by hand. I'll probably still use a mini excavator, but
I was gonna say, enough volunteers and beer.
yeah, exactly. I've estimated crudely that dish could be built by a crew of 5 or 7 in a day.
Sure.
And this, these little things here. This one's 8 inches deep, and can be dug in an hour by one person.
Sure. You got concrete under there? Is that
Yes.
just at the ends, or are you going to eventually have a trough that would be kind of lined with that? Or
This entire design is lined with concrete, and in general, in places that freeze, it seems prudent to make a sort of non-structural layer of concrete,
Okay.
so it's not reinforced. I think this one's about 2 inches thick, and so it's a significant extra use of material. Although here it doesn't add a lot of cost. With freeze-thaw cycles, ground like this will destabilize and push through every winter. I have built them with just this rail system staked directly into earth. It just depends on where you are.
when you're in the future for Bjorn Qorn, you're talking Arizona for larger production? Or?
We still have a lot of headroom here. We're only running this plant at about a third of its capacity now. And it also makes sense to make popcorn in the region that you sell it.
Sure.
Because it's wasteful and expensive to ship it around the country. So it's possible that we will build another plant out west as we expand there, but we'll always have a production presence in New York as long as we're doing it ourselves.
Okay. And Bjorn is growing it for you?
Yes,
in
Bjorn,
Minnesota?
Most of the popcorn comes from his family farm in western Minnesota. Yep. So yeah, they grow most of our corn, but we grow corn with local farmers here too. The farmer Chris Kelder, who lent us a patch of land to dig holes on, grows some of our popcorn, and there's a farm nonprofit that grows organically up the valley here a little ways. Yep.
Yeah. Well, cool. Well,
Yeah.
so Arizona, and how about for the future, just in general, for solar energy, for solar cooking? If you have any ideas, or
like I said, my long-term plan is to build something that could be used at a commercial scale that is solar thermal in the developing world. I've done a couple workshops with our older design in India and in Mexico.
oh, nice.
Which I can give you pictures of.
Sure.
And those workshops were successful in the moment, but didn't have a lot of stay through, in part because of limitations of the design. And we were building small, domestic scale cookers. So it was really, particularly in Mexico, it was mostly just demonstration. But the long-term goal has always been to figure out something that is practical enough that we could set up real bakeries and nut roasters and all. There's a million applications for process heat in this range. That's really what I'd like to focus my energies on next. And as long as we don't hit too many hiccups in the scale up, I think it won't be too long before I have a design that I can go ahead with on that.
Sure.
Yeah.
And so one question I have is, have you looked at the parabolic as opposed to just the
Sure.
circular.
Yeah. So this is an alternative to lower the cost of a large scale dish. That's kind of the concept here, is that by using a circular section, we can build it into the ground, means we can make it big and cheap without worrying about wind load and building a large complicated tracking structure. That's the advantage of this. On every other level, pretty much the parabolic is superior, and the longer operating day, greater aperture efficiency. There is a reason that that's the primary industrial approach. But our hope here is that, obviously those dishes have not gained a lot of market adoption as they exist now. Our hope is that this can be built cheaply and locally to overcome that threshold that the parabolics are not.
Sure. And you could probably build really simple jigs for people to replicate this, right?
Yeah. I didn't even get into that. The part of what is fun about it is that being a cylindrical dish, you dig it with a radius tool. And basically, for the cylinder, there's a track that a little trolley runs in, and a wire that goes down to a digging tool, or a final shaping tool. And you just dig everywhere that reaches. That's all there is to it. There's nothing sophisticated about it. No measurement once you have set the initial posts and guide rail. So by digging everywhere that you reach and then coming back in, either with concrete or with a clay or some finishing material, you can create a very perfect shape very simply.
Sure.
This 50-degree section basically has only a 3-hour operating day. It's not really meant to provide a useful operating day. I was just testing the individual section. But the 80-degree dish should have a 4+ operating day, which is actually down from what we designed the spheres for, which is 6. I made the design change towards fewer operating hours with higher power, higher aperture efficiency, based on the experience of running a business and the concept that it is better to get higher power in a shorter period of time to maximize your production rate. That it makes more sense to, it's obvious I guess, but it makes more sense to make the same amount of stuff in 4 hours versus 6. The only significant disadvantage of that design trade-off is that if you have a day that's partly cloudy, you're limited to the hours that the dish is actually aligned. So you have only a 4-hour window as opposed to a 6.
Sure.
But and actually, in a wet climate like this, that is a interesting disadvantage that we learned about only through operating, which is a lot of the time in a wet place, the atmosphere becomes unstable as you approach the noon hour, and you'll start to build cumulus clouds out of the moisture just in your area, particularly in the summer. So it's typical for the absolute best hours of the day here to have a cloud in the way, which is frustrating.
Yeah.
But in dry places, that's less of an issue. I can throw some coffee in here.
Sure.
You can smell the oils from yesterday starting to heat.
That's oils from the coffee?
Practical setup for this. A stirring mechanism is necessary for most roasting. And I just have a simple rod to reach in there and do it by hand. But that leads to kind of an uneven roast. If we were to build this completely without electrical input, I would be adding a cage with a turn handle stir. And the design that I'll be building next is 12 feet long. So it'll be pushing the edge of what will be practical to stir and load by hand with a device like that. And that'll be one of the design challenges for it. One of the cool things about this, though, is that particularly if you can apply some electricity to run motors, it lends itself to a continuous roasting operation, so that material can be augured through the tube
Yep.
and the auger can be set to so that the residence time of the material is the roasting time. So you can continuously add.
Oh, so they come out one end roasted. And
Comes out one end roasted, yeah. And that would really help the throughput rates. And after trying to use one of these for a business, you realize that is what you need to focus on.
Yeah.
You are trying to make a quantity, and rates matter. So that's why measuring the power of solar cookers is so important, because the power ultimately determines what rate you can do. But one of the reasons this design is such an improvement over what we used to use is you can leave this tube in the focus throughout the entire time and be loading and unloading it without defocusing it. Our first popcorn dish that was commercially practical, popcorn comes out every 5 minutes. And so we were changing a kettle every 5 minutes, which meant the change out time led to the kettle being out of the sun about 30% of the time. So that's huge for the rates to have a 30% loss. And because this stays in the sun, you get that 30% advantage right away. Yet another advantage of the cylinder is it's single axis focusing. So I am looking at the reflection. Whoops! I'm looking at the reflection of the bottom of the roaster in the mirror, and just looking for that band of light, which your camera should be able to pick up there. It'll become more obvious as we get into focus for the day. But because it's single axis tracking, it could also be driven by a clock drive. The rig would need to be counterbalanced so that the load isn't changing all day. But if you added weight to the other side, you could use a very simple, very small motor that's just based on a timer to track the sun automatically. And like I said, the fact that I can load this without taking it out of the sun is a major plus.
Oh, smells great.
Isn't it nice?
There's just nothing like it.
Yeah. So even just set up as this primitive prototype, this pretty much achieves regular batch times for coffee roasting. The batch comes out uneven because it's not stirred continuously enough, but it's roughly the same times as a commercial roaster.
Sure. When you talk about the drainage,
Yeah.
like it'd be, would you have it just at a slight, like?
Yeah, it's mostly just about making sure that the excavation has a path for the water out. So you can see there's a PVC tube right there. Okay. And that goes down to this existing drainage channel here.
Oh, wow. Sure.
So it doesn't collect rainwater. In fact, it rained last night and cleaned it. I didn't need to clean it this morning.
And it just seems like the simpler the better.
Yep.
When you can say, let's eliminate the tracking part, let's eliminate all the drainage here. I mean, no other cooker really has that problem, but you got that. You got to solve that problem.
Exactly.
You solved it with the simplest possible solution.
Yeah, for commercial production, upgrading to tracking and motor stirring could make this totally autonomous. But a 4-hour production day, that's actually still what my factory runs on. We run the kettles for two-hour sessions a day, and that more than meets our needs.
So are you looking at expanding to beans, or you're already doing coffee beans?
I just put some beans in there.
Yep.
You wanna do an image of that?
Sure. Yeah.
I thought you were
Yeah, I got it when you were scraping. We'll.
Some of that smells a little over roasted.
Oh yeah.
So you can see a couple green beans in there, but mostly you've got a light to dark roast. Certainly capable of taking it all the way there.
Oh yeah.
So like I was saying earlier, I found that roasting works well with thin stainless steel because it does not transfer heat well. So the hot spots stay hot rather than the heat dissipating through the rest of the metal surface. And for an oven, that's probably not the best approach. Inside I'm building a kind of neat oven prototype that the inner shell is aluminum so that the heat will dissipate through the metal and heat the oven more evenly, which I think will increase its efficiency, because the oven has the disadvantage of, particularly without glass, as all the designs that I've succeeded with up to this point, you're heating the air on the outside too. That's your main heat loss, and there's no conductive advantage between the air inside the oven and the air outside. And as the air inside the oven rises up towards the stagnation temperature, the heat transfer is more and more preferably to the outside of the oven, because you have colder air there. That's less of a problem when you have a solid, or even better, a liquid directly in contact with the metal, particularly in a batch process where the stuff starts at a low temperature. So you get a good power rate, and you have to be less concerned about conductive loss to the outside air. But the aluminum oven that I'll show you, I'm also doing a little phase change experiment.
Oh, cool.
I'm using not a super efficient phase change material from the actual heat of phase change, but a very effective heat transfer. Okay, so this is another experiment that I'm working on for the same dish out there. This is the inner wall of a phase change oven that will help to stabilize the oven temperature. So the way this works, it's an aluminum tube with another aluminum tube that will be directly in the focus. And this tube will be filled with a tin zinc alloy that melts at 390 degrees. And as it melts, it absorbs energy. So that means the temperature of this thing will tend to hover around 390. When it heats to that point, it'll stay while the material melts, and then more importantly, when the temperature starts to fall, it'll get stuck at 390 as the solder lends its energy of melting to the oven.
Okay.
So it could maintain its temperature through some cloud interruptions, and maybe extend the day a little bit. I'm going to fill this with about 2 pounds of solder, so it only will give a few minutes of complete replacement of the sun, but it should be significantly stabilizing. The tin is a slightly expensive metal, so it might be too expensive to scale this up to where you're doing long-term, 10 minutes or hour heat storage. Unfortunately, lead would be a pretty good material for that, but no, it's all about size. The sun's energy we know exactly its fundamental limit.
Yeah.
And if you want more power, you need more area.
Yes.
There's no way around
Scott.
it. Yeah, and that's why we're advocates of this design, is because it can be made so big without it becoming a super unwieldy, unshippable, wind-prone object.
And if whoever builds it goes out of business, it's kind of a cool retro kind of planner, right? Space age, NASA style.
Right, yeah. Actually, another disadvantage of this design is you can't stop it from focusing.
Oh, yeah.
You can cover the whole thing, but it's a little bit impractical to do that. So it's every day striking a focal line here. And you need to watch out that you're not hurting anyone or starting any fires.
Yes. Is that table in jeopardy, or does it?
It's far enough.
That thing?
It's far enough
Okay.
away. Yeah, it's
You
just,
meant the measurement.
yeah. But if you take the oven off of this crude
Sure.
crossbeam, it'll light that fire.
Yeah. So we're with Bjorn Quenemoen here in Kerhonkson, New York. I'm getting that one right.
Yep.
And we're looking at the whole Bjorn Qorn operation. And it starts with Bjorn's Qorn in western Minnesota.
Yes.
Tell us what got you to leap into this as a business venture, solar, the whole 9 yards. Love the logo on the t-shirt.
Yeah, I'm sporting the solar stuff right now. Well, I I come from the corn farm in western Minnesota, and in college, I realized that people didn't eat as much popcorn as I did, and so I just started making it in the dorm room, and people started calling it Bjorn Qorn, and I started thinking as a kid who was not really positioning himself to take over the family farm, this was a way to make my connection to it, and so I wanted to create this popcorn business so that I could partner with my father, who was still farming at the time, and use the land that we had to make food for people again. And so that was always the plan. The solar aspect came when my good friend Jamie came to me, and I was still trying to figure out how this was going to manifest. And he said, "Why don't we start your popcorn business with this solar invention, this solar cooker I'm working on?" And I thought that sounded good. I really liked the idea of working with somebody on the project. I think two minds are a lot better than one, and are a lot more reassuring when you come and face problems. And so we went forward and worked on his solar cooker while we were building the popcorn business. And it was zany and wacky, and we made a bunch of popcorn, and we're still testing and researching it, and it's been a good way to differentiate ourselves from other popcorn businesses, other snack food businesses, and also have a face-forward approach to alternative energy. It's right on the front of our package. It's the part of the story we tell every time you buy a bag of popcorn.
So you're switching from corn for like biofuel for
Yes, when I said switching back to food for people, I mean that all the grain that is grown on my family farm and around there just goes to the commodity market. And for the most part, none of that goes to human food. Maybe the soybeans do to a certain extent, but the field corn, in large part, go to animals or ethanol, or I think that's sort of a very small portion might go to food processing.
Sure.
But the idea of taking those acreages and making them, like we grew 30 acres in 2020, and that's about 130,000 pounds of popcorn that we are going to turn into a couple years of snack foods.
Sure.
And that's a small amount of land with a big impact for us.
Well, and yeast. I hear there's yeast involved. Now, is that like a special, you've genetically modified this yeast, or is this a family
We're
thing?
not involved in the processing of the yeast.
We don't like the yeast.
We just like it. It's kind of a classic hippie recipe for it. Nutritional yeast is most well known for its application on popcorn, I would say. In vegan communities, it is used for a lot of different things, but I would say its most mainstream use is a popcorn topping.
Cool.
We run into lots of people who really think it's their little secret, and they're like, "I can't believe you did this!" And we're like, "Yeah, well, you're like the millionth person that said that to us." It's just something that never was really marketed because, number one, it sounds kind of weird, and we were the perfect weird company to put it out there. Yeah, we are still only making popcorn. We don't have any plans of any other products at this point, but we are expanding outward towards other regions. We'd like to move into the Mid-Atlantic, which is kind of like the DC area, and the Midwest. We'd like to kind of reconnect with Minnesota, since it is sort of a Minnesota product. It kind of goes back and forth. It's like, you grow it, send it here, we pop it, we'll send it right back to you. It's like a pen pal program in Minnesota. So yeah, that's about it. And the business is going well, and we have a nice team that we are trying to expand as well. So it's fun.
So this is Bjorn Qorn, a solar-powered popcorn factory. This is our warehouse here. All these boxes are what's left of this week's production of finished products. We usually get pretty cleaned out from week to week. We have a great demand. Over here is the kitchen where everything's made. That's not completely tidy because we were off yesterday for Juneteenth, so our weekly clean got pushed to Monday.
Oh, and it's popcorn, man. I mean, you've eaten popcorn at a movie theater, right?
Sure.
Who cares where it falls?
You've got the 4 kettles over there that are about 7 kilowatts a piece, and a tumbling machine. We still hand season everything in batches, and then it gets dumped into these conveyors, which bring it up to weighing machines and bagging machines, which make the final product, gets put in a box, and that's the whole operation basically. We're very regional. We're mostly just in the New York metro area, but we have a few clients scattered around the country too. Like I said, we make all the power that we use in the total building over the year with the solar array that's on the roof, and we'll always expand it to make sure that's the case. It's a great system. I don't know why every business in America doesn't have solar on its roof.
Yeah.
It's just worth it. Yep.